As everybody in the industry knows, the occurrence of defects implies huge expenses for the organizations. There are many reasons for that, but I would like to highlight two. Firstly, the defects, in many cases, must be repaired when they are found, implying huge expenses because of product recalls. And secondly, in some cases, compensation payments and court expenses can be also very expensive. The bad news for us is that, according to the literature, old reference but still valid, more than half of the defects found in software are attributed to requirement problems. Exactly the 56%. Attending to money, over the 80% of the expenses repairing defects go to solve requirements-related defects. In the software industry, it's known that to repair a defect when the software is in production can be up to 10 times more expensive than resolving the same defect during the requirement generating process. But if we consider hardware and software systems, like the industrial ones, this ratio can get into 1,000 times. You can imagine why. To repair a defect found in an aircraft is much more expensive than in a software, because of the physical existence of the product. So the conclusion is really straightforward. The less defects included at the requirements engineering process, the better for everybody. For the engineers, for the organization, and for the customers. So the goal as best software architect is to understand the sources of defects among requirements and being able to identify and retire them. Therefore, whatever activity oriented to find and resolve defects found at requirements engineering process would have enormous added value. As we have seen in previous videos, the requirements engineering process includes two activities coping with the problem. They are named requirements validation and requirements verification. They are our solution. The requirements validation activity intends to assure that the requirements reflect the expectations of their originators, owners or stakeholders. In other words, the validation activity wants that the requirements are representing what the stakeholders want. The skilled practitioners used to say, to do the right thing as opposed to do the thing right. Usually, requirements validation is performed by human reviews. On the other hand, the requirements verification activity sets a focus on assuring the overall and individual quality of the requirements. In practitioners' words, to do the thing right as opposed to do the right thing. Even if we have already explained the distinction, I would like to remember that to verify requirements is not the same than to verify the developed product against the requirements. The first one assesses the quality of the requirements, and the second one controls the quality of the product. Requirements verification is an activity that can be used applying specialized computer tools, or in case of absence of them, by human reviews as well. Okay. So, Juan, how can I verify my requirements? The quality of the requirements must be checked at two levels. At the single level, how good a requirement is, and at the requirement set level, how good the set of requirements is. According to the ISO 29148 standard, the characteristics that must be found in a single requirement to be accepted as valid are necessary. The requirement is connected to the clear need. Unambiguous. The requirement is stated in such a way so that it can be interpreted in only one way. Singular. The requirement is aligned with only one need. Feasible. The requirement is technically achievable. Traceable. The requirement must be connected with needs, other requirements, and/or other work products. Verifiable. The requirement has the means to prove that the system satisfies the specified requirement. I would like to group all of them in a single word: correct. What I want to assure is that every single requirement is correct. In order to do so, 4 working ways can be applied. Metrics working with text analysis, for example, the length of the text. metrics checking information from the requirements management system, like trace, versions, etc., metrics based on semantic knowledge, for example, controlling acronyms, and metrics based on the structure of the requirement, grammatically speaking. For example, having the following requirement. Do you think that it is correct? Yes, you are right. The requirement is ambiguous, and we should have to rewrite it. Is this way better? Well, considering sets of requirements, the ISO 29148 define the following characteristics that must be checked. Completeness. The set of requirements represent a complete definition of the product. Consistency. Not a single requirement conflicts with another one in the set. Do you want to see an example? The set of requirements is shown in your screen. In this example, I am going to use weight expressed in kilos. I hope that you, a super good software architect, can find a way to convert it into pounds. My question is, of course, if the set of requirements is consistent. And the answer is, of course not. Why? Because a bicycle is formed by a crank group, a frame, wheels, and many other parts like saddle, etc. And I know that the sum of the max weights of the three parts of the bicycle is 21 kilo, more than 20 kilo. By the way, I am sure that the sum is not 19 kilo, because a bicycle, at least the normal one, has 2 wheels. I don't want this set of requirements to be accepted. I need to change the weight of the bicycle or change the requirements for the parts. But something must be done. Sooner, better than when the bicycle has been designed and produced. Well, as I always ask myself, can the standards or the community help us in this V&V verification and validation task? Yes, of course. In that case, I want to mention the INCOSE organization. INCOSE stands for International Council of Systems Engineering, and they are the owners of a lovely document, the Guide for Writing Requirements, version 4. And the best for us would be to ask one of the writers of this guide his opinion about this topic. Do you agree? Jeremy, how should an analyst write good requirements?
Thanks, Juan. Here is an extract from the INCOSE Guide for Writing Requirements. One characteristic of a well-written requirement is that it should be singular. For this characteristic, we provide a rationale, a strategy for achieving it, and a set of specific rules that can help. But probably the most important principle to remember is this. It's one thing applying these rules to a set of requirements after they have been written, but far better to apply the rules as you write the requirement to ensure that it's written correctly in the first place. Being able to write good requirements is an essential skill for all engineers. So good luck in your studies and with your future endeavours.
Thanks, Jeremy. Let's summarize. This video has been perhaps a bit abstract and difficult to understand for you. It has been describing what must be done to assure that the requirements are correct, consistent and complete, the 3 Cs, to save a lot of money to your organization. But don't worry, I think that the rest of the videos will be very interesting, so please stay with us. Bye.